Welcome to solverfy.
Basically about the gravitational forces of the moon and sun that cause the tides. And so we want to look at, basically we want to consider the gravitational effect of the moon or the sun on a piece of the earth on the same side as the moon or the sun and on a piece of the earth on the opposite side, and then look at the ratios of these and how much they change. And we're going to discover that the change in the force of the moon is greater than the change in the force from the sun, and so the moon is more responsible um, for the tides, although not entirely. So first, we want to consider the ratio of the forces from the moon for the near and far sides. So just using the law of universal gravitation, we're going to have the gravitational constant times the mass of the moon. And now we're going to say that each little point of the earth has some mass m. And what that is isn't going to matter because we're going to find the ratio between the near and the far sides, and so that'll cancel out. And so this is going to be the Earth-Moon distance minus the radius of the Earth, because we're on this side. So you go from the center of the moon to the center of the Earth and then back the radius of the Earth. And then similarly here for the far side, you're going the distance from the center of the moon to the center of the Earth, and then plus the radius of the Earth. And so this ratio for the moon is going to just be the ratio of these two denominators here. And so, like the problem says we should get, we get 1.6 or 1.0687. Now, for the same thing for the sun, everything is going to look exactly the same as it did before, except we'll have the mass of the sun and the distance from the Earth to the sun. So we're going to get the Earth-Sun distance plus the radius of the Earth divided by the Earth-Sun distance minus the radius of the Earth squared. And so if we stop and think a moment, the radius of the Earth is way smaller than the distance between the Earth and the sun. So we would expect this ratio to be closer to 1 because RES plus RE is almost the same as RES, and similarly RES minus RE is almost the same as RES. And in fact, we get 1.000, so we have to go way further out to start getting decimals that are non-zero, 171. So now in part C here, we want the average force from the sun divided by the average force from the moon. And so for that, we're going to use just the distance to the center of the Earth from the sun and the moon. So we're going to get the mass of the sun divided by the distance between the Earth and the sun squared, and the distance between the Earth and the moon squared divided by the mass of the moon. And the G and the little m of the piece of Earth we're considering cancel out. And so this is 178, like it says it should be. So now what we want to do is to estimate the sort of force difference. It's Fn minus Ff for both the sun and the moon. This is what causes the tides. And we want to do this for both the moon and the sun, and then show that the ratio of the delta F's for the moon divided by the sun is about 2. So in order to find approximately what this is going to be, because if we actually wanted to find this, we'd need to have some hypothetical mass for our piece of the Earth, and that depends on how big the piece of the Earth is, etc. And that's not so good, because we don't know, and it shouldn't matter. But then it shows us that we can first of all rewrite this expression like this. So we know what this value is. We just found this, minus 1, because we just factored an FF out. And then we're going to say that the force on the far side of the Earth is approximately the same as the force at the center of the Earth. So the force difference for the moon divided by the force difference for the sun this is going to be the average force for the moon times our, we already know that Fn over Ff for the moon is 1.0687, so that's 1 minus that, or that minus 1. This is going to be 0.0687. And then for the sun, the average force, and we have the 1.000171 minus 1, so then this is 0.000171. And we already found this ratio. The Fs over Fm is 178, so 1 over that is 1 over 178. And so this evaluates to 2.3. So the moon's influence on the tides is greater than 2 times that of the sun's, even though the force from the sun is greater. The actual difference in force from the sun from one side to the other is about 2 times as small, which makes sense because the Earth's diameter is a lot smaller than the distance from the Earth to the sun than it is, the distance between the Earth and the moon.